X squared plus 25 is called a sum of squares because we can write it as x squared plus 5 squared. So it is two squares being added together. Basically, a sum of squares is never factorable, is what you'll find. So why is it never factorable? Well, there's different ways. You can think about the way conjugates work when you multiply them and go, well, let's look at x minus 5 times x plus 5. Why is this going to work out to x squared minus 25? Well, the reason is that the two middle x's cancel. So x times x is x squared, x times 5 is plus 5x, negative 5 times x is minus 5x, negative 5 times 5 is minus 25. So these two terms in the middle, when you multiply conjugates, will always cancel because of the pattern of the minus and the plus. And when you multiply a negative times a positive, you're always going to get this negative number at the end. Well, how do you get a positive number at the end? So the only way to get 5 squared at the end when multiplying two binomials is to either have 5 times 5, both positive, or negative 5 times negative 5. Okay, both of those are going to give me positives, no matter what. But the problem is that the middle term isn't going to disappear. I'm going to end up with an x term in both of these cases. So x times x is x squared, but then I'm going to have plus 5x, plus 5x, plus 5 squared, which is 25. Or over here, I get x squared minus 5x minus 5x plus 25. So in both of these cases, I end up with these two like terms that don't cancel out, right? With the conjugates, the minus 5 and the positive 5, these cancel, okay? But here they won't cancel, so there's no way to get it to disappear. There's no way to multiply two binomials together and not have an x term in the middle, okay? So this is going to add to 10x, this is going to add to negative 10x. And that's why we cannot factor a sum of squares. A sum of squares is never factorable.